What's up, everyone? I am particularly excited for this discussion today as it relates to like some of my personal interests with regards to like Bitcoin scaling. But today we've got an episode on zkCoins, and I've brought on Robin Linus, Liam Eagen, and John Light to discuss the topic at hand. Guys, I think we can start just with a round of intros. And I think most people in the space probably are aware of who you all are. So I think maybe in the introduction, just relate, maybe just tie in why you're interested in zkCoins, why you're working on it, as well as along with the introduction. So I guess we can start with Robin to kick us off.
Yeah, thanks for having me. Um, I'm excited about zkCoins because in general, I like Bitcoin, the currency. I like Bitcoin being used for payments. And yeah, for that use case, what we need is mostly privacy and scalability. Those are the biggest pain points. And zkCoins is a way to address them and to make Bitcoin more scalable and more private.
Kick it over to Liam now.
One of the original reasons that I decided to work on Bitcoin and cryptocurrency and cryptography generally was to bring private payments to people, and obviously people have been working on this for a long time, and I think that zkCoins and the client side validated paradigm was probably not consciously, but maybe at some level like the end game for all of that work. And somewhat recently, I think Snark performance has increased to the level where it's actually feasible to do that. And I guess relatedly, but in parallel, this is a way to bring private payments to Bitcoin specifically, essentially without changing it at all. Which I don't know, that collection of things is sort of what I'm in it for. So
Very cool. Very cool. And Light, I think a lot of like your research related to validity rollups and these types of systems was also focused on kind of bringing, private style, maybe Zcash style payments over to Bitcoin. What's your particular interest in zkCoins as well? Because, you and I have talked and you seem very excited about it as well.
Sure, yeah. I work with Liam at Alpin Labs. I'm also a research advisor at Bitcoin Layers. And I'm interested in zkCoins as a more scalable alternative to Zcash style encrypted payments. I see it as the next evolution of encrypted money that solves some of the problems or pain points with predecessors such as eCash and shielded blockchains.
I think, Robin, at a high level, what is this? What is this like protocol? What is zkCoins? I've heard you call it taproot assets on steroids before. Just really, yeah, like at a high level, how does the protocol work, and what's the purpose of it?
Yeah, taproot assets on steroids is one explanation. Because if you're a bit familiar with taproot assets, then the most simple explanation is that it's taproot asset combined with snarks and a couple other tricks to make it a bit more efficient. But on an even higher level perspective, I would say it's essentially the idea of how to make eCash trustless. That's actually how I started. I started with the idea of eCash, and then I thought about how can we remove the mint, or like how can we remove that trusted role of mints, and then that led me to this design essentially. And yeah, it's a client-side validation paradigm, just like Taro or RGB, or also you could compare it to stuff like OmniLayer or Counterparty. These are all kinds of protocols that are just embedded consensus protocols. They just use the blockchain as like essentially like a data availability layer. So you inscribe data into the blockchain, and then you can have custom clients that just read the blockchain, and then they reason about what the state of this embedded consensus protocol is. And you're essentially piggy banking on top of Bitcoin's consensus. And the problem with these is that if you do it naively, just like the first versions, like Counterparty and what was the other one, OmniLayer, they were quite wasteful, more or less, because they needed Bitcoin transactions, and then in these Bitcoin transactions, they had to also publish some data. and those were just a bit wasteful in terms of block space, and that's why the more modern client-side validation protocols such as RGB and Taro, they try to like take as much data as possible off-chain and just commit to the to their protocol's data in Bitcoin transactions, but not put the actual data on the Bitcoin blockchain. And that is a bit more efficient. And what zkCoins does is that it doesn't even use Bitcoin transactions anymore. It just uses block space, so similar to inscriptions or so. You just have some block space that you can arbitrarily define. For example, every transaction that starts with a time log that is 420 or something, that is counted as like a zkCoins transaction or the zkCoins inscription transaction, and then whatever is in that inscription transaction will be interpreted by the zkCoins protocol. And the good thing is that it decouples zkCoins transactions from Bitcoin transactions. So even if you had like a billion zkCoins transactions, you wouldn't have to have a billion Bitcoin UTXOs. So you don't bloat the UTXO set, which is a fundamental difference to RGB and Taro. And this is done mostly by combining it with snarks, with this compression technique. And what that gives you is that in general, in these client-side validation protocols, you have the problem that the recipient has to send to the sender a history proof of the coin. So you, as the recipient, you are the party who is incentivized to check that the entire history of the coin that you are receiving is actually correct. It's not verified on the base layer. It's not that other Bitcoin nodes would care about. Like on the Bitcoin protocol itself, everybody verifies everything, and I verify the transactions of everybody else. In zkCoins, that's not the case, or in general, in client-side validation protocols, that's not the case. In particular, like in the modern ones, RGB and Taro, there only the recipient verifies the history of a particular coin. And this history, it can grow a bit too quickly. Like in general, every transaction has at least one input, but on average more than one inputs, and that gives you like a tree of history, and that grows a bit too quickly. So it would be quite cumbersome if I want to send you a coin and I have to send you like 2 gigabytes of history data or something. That would kind of defeat the purpose, and it would be impractical in many cases. And that's where those snarks come in. So we use these snarks to just compress the entire history in a succinct proof that is just way less than a megabyte, and I can easily send it to you, and you can quickly verify it. You just, in a blink of a second, your phone can verify such a history proof, and that makes it much more ergonomic.
So essentially, we're taking essentially, like, if you and I are engaging in a transaction, I send you X amount of coins, and then you solely are just verifying the history of that specific like coin set, and like you're verifying that history, and then you're storing that state, and then updating it, every so often by posting a transaction onto the main chain.
Yeah, whenever you want to do a transaction, then you're updating.
Is, if you might have explained this, but like throughout this process, like what are the various like components in the transaction lifecycle? So you and I'm sending you a transaction. I'm not engaging with anything like, within like a side chain. Like I'm submitting it to like the sidechain mempool, and the validators will like build the blocks. Like I'm just sending this to you directly, and we're keeping a track of our own state, and then we're just updating that state, regularly through a commitment onto the Bitcoin main chain. There's no like other sequencer or validator set that's involved in these transaction life cycles, correct?
Not quite. It is good to batch many transactions. So you will have something like a sequencer. We call them publishers, and they can, or like they want to batch as many transaction commitments as possible. So zkCoins users would send their transaction to these publishers, and those publishers would then batch them into Bitcoin transactions and then publish these Bitcoin transactions. And if all publishers would want to censor you, you can just publish your own transaction. It's just a bit more expensive because you have to pay for your own Bitcoin transaction. And
I think we call them nullifiers in the current version, but yeah, it's trustless, but can be batched for efficiency reasons.
Cool. So I guess how I'm understanding this then is that this is just a way to increase the transaction throughput and then, create another system that allows users to scale Bitcoin payments at a higher level. How does the privacy aspect, like how do you achieve, near perfect privacy? Because I understand that you're compressing the data with validity proofs, but how do you, obscure the transaction graph and like have better privacy guarantees with this?
So I think I don't know, I guess maybe related to the last question a little bit, but in my opinion, this is part of like almost like a convergent evolution of a bunch of different kind of strains of work. And so one of them is the like zero coin Zcash style privacy, right? And so then the way that works is you have a sort of set of transaction outputs and a set of nullifiers. And when you publish a new transaction, you add the outputs of the transaction to the output set and you nullify some existing outputs from the output set. And this is to allow people to check for double spends. And it requires putting the proofs on chain, right? So like the way in which that this is kind of an evolution of that is that we're able to avoid putting the proofs on chain. And like Robin was talking about, the way that works is we have this recursive validity proof thing. And in one sense, right, you kind of get privacy for free in the client-side validated setting. There's nothing on chain except for these nullifiers. And so as long as you ensure that the nullifiers are not linkable, and you ensure that the client-side validated proofs, the snarks or narcs or whatever we end up using, are blinded or hiding, right, zero knowledge, then, I mean, it's a little hand wavy, but I think people can probably see how you basically get privacy for free. You're not putting anything on chain that would identify anything that was related to anything else. And as long as the client side validated transaction history proofs are also zero knowledge, then you just get privacy, which is pretty cool.
No, that is interesting because when you're initiating the transaction and submitting that validity proof, you're obviously just only like revealing a statement that you can prove that all of this is true without revealing the contents of the statement. So when you're submitting that transaction, like if Alice is spending some coins to Bob, Alice isn't revealing how many coins that she has. She's not revealing her past transaction history. She's just saying that I can verify that this coin that I'm spending to you is like I'm verifying the validity of this specific transaction based on X, Y, and Z, right? It's not like revealing the entire contents of their balance or their transaction history.
Yeah, exactly. It's hiding everything that you want to except for, what you choose to reveal. And what you choose to reveal is probably just that the sort of history is valid and whatever information is necessary for the recipient, like how much money they are receiving. I don't know if the audience is familiar much with snarks, but I mean, they really are kind of a magical technology, and they're a perfect fit for the client side validated paradigm. And I think it's honestly kind of surprising that there's this sort of glaring omission in the other client side validated protocols, or they're I don't know. I feel like that snarks are underused, so to speak, and that's kind of how I came at this originally. Yeah, I mean there are projects, so it's worth mentioning probably that there's this project in the Ethereum ecosystem called IntMax2, which is very similar to the zkCSV paradigm, and it kind of comes out of this parallel work on Plasma in the Ethereum world. I'm not sure exactly what the like intellectual trajectory was, but I mean, I like, Peter Todd obviously worked on client-side validated stuff a long, long time ago, and there was like this vague sense, right, that you could combine snarks to solve the transaction history problem. So it's cool to see this all like actually happens.
Yeah, it's totally worth mentioning that Peter Todd already talked about this stuff 10 years ago or so. He wasn't very precise with it. He just said, like, kind of hand wavy, if we had snarks that could solve it, then that would be great. But he definitely wrote blog articles about it already almost 10 years ago.
And I think it's worth reiterating the point that Robin made earlier, that decoupling the zkCoins transaction structure and data from the Bitcoin UTXO set is like a really good idea that, as far as I know, the other client-side validated protocols don't do.
That is also very critical from the perspective of blockchain scaling in general. Like when you want to scale blockchain by just increasing the throughput, you run into multiple issues, and only one of them is network. That's what many people are aware of. Yeah, of course, you have to send all the data over the network, but that's often really not the bottleneck. A bigger issue is the growth of the UTXO set, because all the nodes have to have it in memory, essentially, or in particular, the miners have to have it in memory to be able to validate blocks fast enough so that they can start mining as quickly as possible. So we solved that problem. And also the other issue is that verification of blocks is usually costly. And zkCoins increases the throughput, but reduces the cost of verification, because full nodes just don't have to verify the data that is put on the Bitcoin blockchain from the zkCoins protocol. It's just arbitrary data for them. They don't care if it's an image or if it's zkCoins data. It's just the same for them, just random data. And that makes it easier to verify blocks, which is quite interesting, because you would expect that it becomes harder to verify blocks when it has like 20 or 10 times more throughput, but actually it becomes easier.
Like from your vantage point, how do you feel like these systems differ from maybe the roll-up implementations that people are looking to build, and how do they compare to things like, Aztec or other proposed like privacy roll-up designs and other ecosystems? I'm just curious, like from someone who's studied the roll-up side of things a lot, like how do you kind of view these systems and how they compare, and what are the trade-offs?
The main differences that come to mind for me are that in the shielded blockchain model, users are putting the full transaction data on chain. In Zcash, this is several kilobytes of data per transaction. In Aztec v2, this is about 700 bytes of data. And then every full node has to download and store this data once the shielded transactions are confirmed in a block. We can think of all of this data as creating a global state that all full nodes have to be aware of. In the CSV model, the global state is much smaller on a per transaction basis, and most of the application state is held client-side, hence the name, client-side validation or client-side verification. Users don't need to be aware of each other's application state because they're only putting the nullifier for their transaction on chain, so that's all of the other users see. Users can also batch their transactions together so that multiple transactions can use the same nullifier, which multiplies the cost savings. And I should mention that the nullifier that goes on chain is less than 100 bytes. So, and you can amortize that, like I said, across multiple transactions. The rest of the transaction data, like the ciphertext and the ZK proof, are sent to the recipient out of band. For example, it could be sent to the recipient in an email or a text message or something like that. So that data doesn't need to go on chain, which increases the scalability and reduces the costs compared to shielded blockchain transactions. One more thing I'll mention here is that the zkCoins model and the shielded blockchain model are not mutually exclusive. So if for some reason the sender or the recipient doesn't want to do the transaction messaging out of band, the sender can just put the transaction data on chain along with the nullifier, and then the recipient can scan the blockchain to find their transactions and sync their wallet balance. So basically the zkCoins model can actually fall back to the shielded blockchain model if needed.
One really interesting thing about zkCoins is that you can actually use Starks or Fry-based post-quantum resistant, no trusted setup proofs, which for something like Zcash would be at least an order of magnitude too large to be practical. And you can use them with zkCoins because you never have to put the proofs on chain. It's only ever communicated to the client. So even if your proof is 100 kilobytes, I mean, you might want it to be smaller than that, but that's not like a deal breaker. Whereas if you wanted to do a classical private zero coin style payment protocol and the transactions were all 100 kilobytes, you'd have like at least 30 times more data than they currently do. And that would probably be pushing the limits of feasibility. And I also did want to I'll stop in a minute, but I just wanted to also say that one technical point is that zkCoins does not completely eliminate the obligation of the client to pay attention to the global state in order to construct the transaction validity proofs. And this is actually one kind of subtler point that we're Robin and I and Jonas Nick from Blockstream are addressing in forthcoming work is how to construct the transaction validity proofs and what dependence does that have on the kind of global nullifier set, right? Because in order for your transaction validity proof to be valid, you have to prove that you sort of haven't double spent. And so the way that Robin describes it in the original note, and Robin obviously correct me if I'm wrong, is through something you might call exclusion proofs or non-inclusion proofs, where you show that your nullifier has not been published on chain. And in order to do that, you need to kind of run essentially a zkCoins full node. So you keep track of all the nullifiers, you prove that your nullifier isn't in the set. And one really nice property about this is that you can have these epochs where you just have one proof that you didn't spend it over the last month, and then all the full nodes can kind of forget the nullifier data. Another approach is to use inclusion proofs, which is more similar to how Zcash works and that style of protocol, where the flow is something like, to send you money, I first nullify and then prove that I've nullified. But in either case, we have a dependence on the global nullifier set. One advantage of the second approach is that you can potentially play with things in a way where you have less of a dependence, but it's unclear at the moment whether that's true or to what extent.
So I want to touch back, and Robin, I have a question for you on this. I want to touch back to what Light was talking about earlier with regards to not having this idea of global state and everyone having to download every kind of transaction that's been recorded on the ledger to be able to discern which transactions they think they can decrypt. Is this when you were designing this protocol originally, were you looking at things like roll-up style blockchains or something like Aztec or a Zcash style roll-up as a potential solution to private payments or private payment solutions for Bitcoin? Or have you always been more drawn to this client side validated protocol? I'm just trying to understand what your kind of motivation for going in this direction was originally.
Yeah, I didn't start out with thinking about zk rollups much. I thought more about the privacy aspect, and I think you can achieve some level of privacy in a zk rollup, but you still depend on that sequencer a lot, and that's why I thought more about eCash. I really thought about how to improve eCash or how to get rid of the trust assumptions that are necessary for classical eCash protocols. And getting around that sequencer was quite crucial, I think. And yeah, in the rollup world, they're trying to decentralize the sequencers. That's I think an ongoing research topic. But it usually introduces lots of complexity, and it's just not an easy issue. And here in zkCoins, it's pretty trivial to solve it because yeah, if all the sequences are censoring you, then you just use your own Bitcoin transaction. And as long as Bitcoin is censorship resistant, you will get your zkCoins transaction in there. So there is no really any point in for a sequencer or for these publishers to try to censor you.
I was just going to say, along this eCash point, I mean, so people, especially in the Bitcoin space, are probably, reasonably familiar with eCash, but there are two ways in which zkCoins and the kind of like I said, there's this convergent evolution sort of thing, but like the Zcash part of the convergent evolution differs from eCash in this extremely important way, which is that the eCash mint or mints or federation of mints or however you end up setting it up can do undetectable inflation, or alternatively, you could view it as theft, because all they're doing is blind signing. So they can sign new coins into existence and give them to themselves, and it's not only impossible to detect, but it's impossible for them to prove that they haven't done this. So it's sort of like um, structurally impossible to audit. And the advantage of the approach, given this significant trade-off, is that the user can be, I think, essentially stateless. They have no dependence on the global state at all. They just keep track of their own coins, and they do the blind signing transaction procedure with the eCash mint. And the mint is responsible for keeping track of the nullifier set, which does also an equivalent kind of object exists for eCash, and they have to keep track of it. So I think that using zkCoins in the context of something like an eCash is definitely interesting. Like Robin sort of says, right? You can have verifiability then, or another way in which it's different is you could use it with Bitcoin, right? Like the person who's keeping track of the nullifier set is substitutable. It can be a blockchain like Bitcoin, it could be a mint, it could be a collection of mints, it could be um, there's probably other interesting options, but I'm not thinking of them right now. So yeah, just it is, I think, crucially different from eCash in this.
Is that a way that you could optimize the system? Like if you don't want to like have to post the full nullifier set on chain, you could just like use a collection of different mints and the user could potentially select where to post where to post data. Is that like a way to optimize the system in any way? Like could you use a Fedi mint, for example, to take on this role?
I mean, I'm not sure exactly what we mean by use a Fediment to do it, but you could have a federation of people that handle data availability for you. Maybe another intermediate solution would be to put all of the nullifiers on a data availability layer like Celestia that has less uh, robustness, perhaps, than putting them directly on Bitcoin, but still offers some kinds of, assurances about their availability. Because you do kind of, in actually both the inclusion and exclusion version, you need the nullifiers to be available for like some period of time. So but yeah, you can delegate this to a third party, a collection of third parties, some other kind of distribute-ish protocol.
Okay. So actually before we I want to touch on like the user experience side of this and how like just simply interacting with this protocol from a user perspective compares to different solutions in the space. So I guess something I'm more interested in here is like just a simple like question to start this off. Like if I'm a user, I'm interacting with the zkCoins protocol, let's say via like a mobile wallet. Is the onboarding experience similar to that of Lightning? Is it similar to that of like, you mentioned client side validated protocols. Like, do I need to use an L1 transaction to onboard into the system? Like, what's the typical like user flow of just interacting with the system for the first time?
Yeah, every transaction needs an L1 transaction. It's essentially more like Bitcoin L1 transactions. The main difference is that they are private and that they are much more compact. But in general, it's very similar to how a Bitcoin regular L1 transaction would work. So in comparison to Lightning, you don't need any inbound liquidity or something like that.
Then the difference maybe then is that we're just compressing this transaction size down to a very small amount. And is that, so we're not, let's say, engaging in, let's say, we're not posting data to the L1 like every 8 hours or so. We're just like every time we engage in a transaction, like I send you money, we're then posting a relevant like update in that state to the Bitcoin L1.
More precisely, whenever you update your account, because in theory you could send a transaction to 1 billion people in just a single commitment.
Okay, so how does this then, like, are we just like minimizing the amount of data that we want to put onto the Bitcoin L1? I'm trying to understand, like, I guess some of the value of, like, let's say we take all of the transactions off chain in terms of like the data that we post. Like if we're only posting every 8 hours, then we can compress that data and then have a very minimal amount go on to representing the state difference. Like if we're doing an L1 transaction, is the user incurring some type of, like, are they incurring the cost of that with having to pay transaction fees? What's the kind of, from just a UX perspective, are they able to, like, are they passing that on to the publishers? Like what's the, I guess, UX perspective of, like, if I'm trying to engage in just like a number of transactions every day or so?
Yeah, that's an important point. Usually in client-side validation protocols, there's an issue when they modulate the transaction on top of Bitcoin transaction. That means you need to have Bitcoin to send, for example, your Tether. And that is quite annoying because if I send you, I don't know, $10 in Tether, you want to be able to spend them, but you're not able to spend them until you buy some Bitcoin. And that is a bit cumbersome from a UX perspective, of course. And in zkCoins, that's solved by these publishers, because you can pay these publishers in tokens or whatever currency you have, if it's Tether or like private BTC or for whatever you're using the zkCoins protocol. And as long as the publishers accept that currency, they will put your commitment on chain, and they will pay the Bitcoin fees for you in that batch transaction. And yeah, it's cheaper than regular Bitcoin transactions, of course, because you need less data.
Yeah, I just wanted to shout out Jonas specifically. This is like an easy thing to describe how to do. Yes, you can pay fees to the publishers in the client side validated layer, and then they incur the cost of paying the Bitcoin fee to inscribe the data. But while it is easy to describe, it's actually fairly complicated to make this work in a way that you would want the fee market to work, right? So you don't maybe want to pay a specific publisher. But one interesting problem that comes up in these private transaction protocols and as well as zkCoins is, in Bitcoin you can do things like have pre-signed transactions that sort of just work out of the box. In zkCoins and private transaction protocols, there's this chicken and egg problem that occurs where you can't construct a valid transaction until all of its inputs, or in the case of zkCoins, all of the associated nullifier data has settled, basically. And so you can't pre-sign the transaction if its inputs haven't like been produced yet. And then this is closely related to the fee paying problem, because you want to kind of like pay the person who puts your data on chain, but you don't know who they are, and you can't construct a transaction paying them because your data isn't on chain yet, but you don't want them to be able to get paid unless they do it. So anyway, there's a nice solution that we have for this using multi-step kind of like proofs. But in any case, that, yeah, reiterating, Robin is, yeah, that's how you would do it, and this is kind of like how you would do the thing.
Could you describe like the multi-step proof solution a little bit more?
Well, it depends on whether we're using inclusion or exclusion proofs. But just, I would say at a high level, right? Like the normal flow is, if we're using inclusion proofs, say, I nullify my transaction, and then I construct a proof that I nullify my previous account state. I prove to you that I've nullified my previous account state, and then the nullification of the previous account state kind of commits to the payments that are originating from the previous account state. And then I prove to you that one of the payments that I have committed to is a payment to you. and that sort of the account state transition is valid. So I didn't create any new money. I didn't do anything nefarious. Maybe I even like adhere to some kind of smart contract. So in the fee payment example, it breaks down in the first step. So the first step was nullify and then prove that I've nullified. So I can't prove to the publisher that I've nullified because I haven't nullified yet. They have to nullify me. So you split up the transaction validity proof into two parts where you prove everything except for the nullification. So that would be like whether I haven't created any new money, all of the new outputs are valid, etc., all of this. And then there's a special kind of path in the proof graph, which it's a little technical, but there's this concept called proof carrying data, which is very kind of academic, but it's a useful, actually, it works very well with the model that we're working on. Basically, you have a graph of states, and each edge in the graph has an associated proof. Or I suppose you prove each transition is valid, and then what you can do is if your graph is a DAG or it's directed acyclic, you sort of walk backwards, and each proof proves the validity of its incoming proofs. So in our case, right, there's two nodes. There's the prove everything is valid except for the nullifier. And then instead of me constructing the nullifier proof, which I normally would do when I'm paying a normal person, we allow the publisher to construct the nullifier proof themselves because they have the information, right? They're going to have the witness after they've published it. But this removes the dependence basically. And so that's the multi-step thing I was talking about. Sorry if that was a little technical.
Light, I wanna tag you back in. Like, what from your perspective, how do you kind of see this system interacting with systems like rollups and being a part of, I guess, because I guess in rollups everyone has this idea of like a super chain thesis, and there's a lot of different chains that optimize for different use cases and trade-offs. Like, how do you kind of foresee zkCoins interacting with the future of like let's say there's like a plethora of side chains and different L2 designs on Bitcoin?
One way that we could imagine these different systems interacting is that users could treat their zkCoins account as like the shielded account where they're just holding their funds, and then they can also use this account to make peer-to-peer payments with other users that are relatively low cost due to the minimal amount of data that needs to be put on chain. But then, if they want to do things on a blockchain like a rollup that requires, some kind of application that requires global state, like liquidity pools for trading or borrowing and lending, they would be able to interact with these different liquidity pools from their zkCoins account. And so, they would incur some additional cost in doing so because now they have to interact with this global state application, and that requires the user to put more data on chain. But it adds some layer of privacy to the transaction because the user's account balance in their zkCoins account is shielded. All of the assets that they hold in that account are also shielded. And so there's only a minimal amount of data that actually needs to be made public to say get a loan or make a token swap or whatever the case may be. So yeah, I think it could just be the default way that users end up holding their funds, and then from that shielded account they'll be able to interact with these other kinds of protocols that might require global state. But if they do just want to make a peer-to-peer payment, then they can do that using zkCoins, and it'll be relatively low cost and of course like private.
Is there any issue with, like, so in zkCoins, right? You can hold any kind of certain amount of tokens. So let's just say, for example, it's Bitcoin and Tether. Like, is there a way to have those token standards be, I guess, mimic those of other systems so they can be interoperable with other systems, like you just mentioned, maybe like a system that has like borrowing and lending applications, right? I'm just trying to, like, I'm imagining a world where I can take coins from my zkCoins account and just bridge them over. Or are you likely going to be using things like atomic swaps? Like, how do you envision like the interoperability side of that?
The way that I'm thinking about this is that you could either have a contract that translates between the two token standards if they need to use different token standards, or you could just have the zkCoins protocol use a particular, like, recognize a particular token standard. So you could, let's say, have a roll up or a Validium or something like that, which is like where your zkCoins protocol lives, and you make the zkCoins contract that users actually deposit their funds to, like Bitcoin or other tokens, like aware of, let's say, ERC20 tokens or something, some other kind of token standard. And so you could just send ERC20 tokens like to that contract to make a deposit into your zkCoins account. But there could also be some sort of translation layer where, like, users lock up ERC20 tokens on the EVM chain, and then a zk proof is used to basically prove that you locked up the tokens over there, and enables you to mint the tokens that are actually compatible with the zkCoins layer, if they use a different token standard. Maybe just because they're using a different execution environment. So it's not exactly like an ERC20, but it's, some kind of way of minting tokens. I don't know. I think that this is a, like, pretty easy to solve thing. It's just a matter of tying these different chains together, perhaps using zero knowledge proofs to show that you've, spent some coins over here and you're unlocking coins over there, and vice versa.
I just wanted to say to your question about whether people will use swaps or bridges. I guess concretely, Robin, I mean, obviously, tell me if I'm wrong, but I think in the BitVM bridge, kind of pure zkCoins plus BitVM layer for Bitcoin, the idea is very much that people will use atomic swaps instead of the bridge, because the bridge is very expensive to use. It's meant to be like a big, like net settlement layer that some like liquidity provider might facilitate.
Yeah, no, totally get it. I mean, I think though conceptually, right, the idea of having kind of this second layer, side layer protocol that where I can store my funds, and still have like the ability to submit that L1 transaction to update like the state related to my account permissionlessly. Like, let's say if one of the publishers wants to censor my transactions, or none of the publishers want to do that on my behalf. Like, I think that conceptually is really interesting, and it allows me, like Light said, to be able to, once these protocols are in place, like to have that place to have a private account balance and then interact with these protocols in a much more private way. I think, like, for the long term, like use of these types of solutions and use of Bitcoin, I think that makes like a ton of sense. I think, kind of, Robin, I think, wrapping things up here is like, what are the next steps? Like, what are the next steps related to zkCoins? I know you and your team are heads down on BitVM2 right now. What are the next steps related to developing BitVM2, zkCoins, and getting things like this into production?
Yeah, with Liam and Jonas Nick, we are working on publishing a paper on zkCoins. And yeah, just to repeat again, Jonas is doing great work there. Actually, Liam and I, we are more like the ideas people, and Jonas is like the down-to-earth person.
I think more fairly to us, we've been focused more on BitVM lately. I started working on this paper more actively when I was still at Blockstream, but yes, Janusz absolutely has done great work, and hopefully it will be done soon.
I just want to stretch for this paper. He's doing lots of the hard work, and yeah, just wanted to mention that. And yeah, we hope to finish that paper soon, and then we can start with the implementation. I feel like most of the issues are resolved by now. There's a couple things left, but the bigger picture is quite clear now, and there's not that many question marks left. We're gonna start implementing it soon, and hopefully we're gonna have a prototype that people can play around with by, I don't know, within the next year or so.
Okay, very cool. And in the meantime, if obviously BitVM is a huge part of this, giving people the ability to bridge assets over to a protocol like zkCoins, in the meantime, is the best place for developers and researchers to contribute. Is it going to the BitVM builders Telegram chat and participating there to enable like the bridge protocol to obviously make zkCoins have less trust assumptions? Is that the best place for people to get involved right now until the paper is released and prototypes are available?
And the good thing about BitVM is that many other projects are interested in it, and they help complete it, and they help. In particular, also they want to help with the hardening and like all the complicated stuff at the end when it's actually implemented. So it's it's looking pretty good for BitVM too, and yeah, hopefully by the end of this month we will have the first prototype ready.
Amazing. And before we wrap up here, for each of you, where's a place where people can follow your work and stay up to date on your work, whether it be social media, profile, website, etc.?
Twitter, yeah, Robin_Linus. I think the easiest way to get in touch is certainly the BitVM Builders channel on Telegram. If you just go to bitvm.org, you will find the link to the BitVM channel.
Okay. And Liam, for yourself, best place is Twitter?
Oh yeah. Well, no. Well, yeah, that might be the best place, but it's probably not a good place. I struggle with self-promotion, so I will say though, if anybody's listening to this and they have like a lot of experience with Plonky 2 or some other kind of recursive proof system and they're interested in working on this, definitely reach out. We have a few ideas about how to implement it, and I mean, I've talked to some people, but I think the most efficient way would be for somebody who is very familiar with. Um, I guess we're kind of open-minded about exactly how, but some kind of recursive proof system. So there's like some folding libraries that have matured recently, or more recently. Plonky 2 has been around for a while, but yeah, whatever. We're looking for collaborators on that front.
Okay, awesome. I'll be sure to link that as well. Link contact information. Light, is there a specific place where people should follow your work as well?
I try to post updates fairly regularly on my website, lightco.in, lightco.in, and I'm also fairly active on Twitter, twitter.com/lightcoin, lightcoin.
Awesome. And I'll link all that information with regards to the various Telegram chats, Twitter accounts, websites in the show notes. So everyone can just check those out to find all the information there. Guys, thank you so much for hopping on today. This is something I'm really interested in, really excited about. And yeah, hopefully we were able to dive into it a little bit deeper and share what's coming for everyone interested in these types of solutions on top of Bitcoin. So yeah, thank you guys so much for joining.